properly?
Yes.
Hello. Okay. So in the last session, we covered the SDLC and SDLC phases. Okay. Uh, so it is just continuation of this topic. So the next topic is testing labels. Okay. So what is test label? So test labels are basically referred to the different stages of testing activity. Okay. So for example, unit testing. So unit testing focus on the individual component or unit of the code. So basically this is done by the mostly it is done by the development team. So they perform some unit test and then they share that result, and after that we get a code for testing. Okay. So basically in unit testing we verify that each unit function is working as expected and it is like performed by the developer. Next is integration testing. So integration testing, like it's a integration between unit or component. Okay. So as a feature, right, there may be a lot of uh, like component in one particular user story or one feature. When we combine that, then how it is working. So this is to ensure that different modules or services work together. Okay. And this can be actually performed by testers as well. Sometimes developer also do some integration testing. Okay. Next one is like system testing. So this is like focus of this particular test level is to test entire system as a whole. And we actually verify like system is meeting the requirement which is specified. Okay. And this is performed by tester. Next one is the so once the testing is completed before launching the product, so we perform some kind of user acceptance testing. And so this goal of this testing is to confirm like product meets the business requirement and like it is ready for release. So basically in this one, we involve some end users, customers, and the QA testers. Okay. So any question on testing levels? Good. So here like definition is there. You can go through it. Next, testing type. Okay. So so in testing type, like we have test type are like different categories of testing activities, and in this each one is focusing on a specific aspect of the system behavior. Okay. So we have unit testing, integration, regression, smoke, alpha, beta, system, stress, performance, object-oriented testing, and acceptance. So these are all are different testing types. So I'm not going to cover this four because we have already covered. So mostly I'm focusing on the other type of testing. So basically, you know, these testing can be divided into two parts. We can actually club this in functional and non-functional, right? So in functional, basically we check the software function as expected according to the requirement. For example, smoke testing, regression testing, sanity. In the non-functional, so basically we have like performance testing, usability, reliability, or security. Some testing are not mentioned here. So those are part of the functional testing. Okay. Now, what is regression testing? Okay. So simple definition of regression testing is like regression testing is performed to make sure like because of any new feature implementation and bug fixes, there is no break in the existing functionality which was already working. Okay. So this is very much important. Like if any bug fix will happen, any new feature will be developed. So developer will actually push the code and that code changes should not affect any existing functionality. So this is very, very important because it might break the feature which are already working, being used by the customer. So this is very important to actually perform this testing. And when we perform regression testing, so we perform regression testing every time whenever there is a modification or update to the software. Okay, clear? Hello.
Yes, Raju.
Yes, yes, Raju.
Okay. Next one is smoke testing. So basically in smoke testing, we check the core feature of the software. So it should work correctly. And we ensure like application is stable to actually start the detailed testing. Okay, so whenever we get any build for testing, the first thing we should do is we should perform a smoke test to make sure like application is stable and now we can go ahead with the detailed testing. Okay, so it is like smoke testing should be very quick. It should take very minimum time and like this can help us to identify critical problems at the early stage, right? So if you do this smoke test properly, maybe some blocker issue, something is there, you can identify on the very first day itself. Okay, sometime it happens like you have not done the smoke testing, you have started with the detailed testing and you started with some feature which is like stable and then on the last day of your testing you found like okay there is some critical issues. Okay, and that might actually impact your release also. So it's very good practice to start with the smoke testing to make sure like you don't have any blocker issue. Okay, next one is alpha testing. So basically alpha testing is mostly actually conducted in the control environment and it is typically carried out in a lab or internal environment by the development team itself. And they actually focus on simulating real world users condition as closely as actually possible. Okay, it can be also conducted by internal, uh, I mean, testers, developers, sometime end user also. Okay, so it has actually two phases basically. Okay, so in the first phase, like it is performed by developer and they focus on the immediate bug fix or improvement of the software stability. And in the second phase, basically it will perform by like a specific testing team. And this involves more rigorous testing to identify issues that might have missed actually in the phase one. Okay. And when we do this alpha testing, so before the beta testing, we should perform this. Okay. So that we can identify the bugs at early. And during the feature completion also, we can actually do this. Okay. Next one is the beta testing. Beta testing is like conducted by real user outside of the development team. Okay. So it takes like real world environment. So you might have seen like um, some apps are actually released as a beta version where the user can come, they can sign up and then they can use it. and also they provide the feedback. Okay, and they try to actually, you know, we try to gather the issues that might missed in alpha testing, basically. Okay, next one is uh, system testing. So this is like most important actually aspect in the testing. Okay, so like basically like when as a tester, right? So the key aspect I would say, like in this system testing, we test the entire software system from start to finish. Okay, so basically it's like a end-to-end testing. Okay, and this is mostly like a black box testing technique. Okay, and the focus is like, you know, you focus on the input, expected output and user interaction within the system. Okay, we actually perform the validation against the requirement. So whatever requirement is captured, like, based on that, we actually ensure that system behave as expected and it meets the user's needs. Okay. Uh, System testing, again, like it can include both functional and non-functional also. And we try to actually test on realistic test environment. Okay. And because if we do this, this will help us to identify the issues that could occur under real world condition, right? Because at the end, this product is going to be used by the users outside of our organization. And in the system testing, like we can perform functional, performance, security, usability, compatibility, you know, error handling cases. So these kind of testing we can do. In compatibility, I think it is not mentioned here. So basically, this in this phase, we verify that software works across different devices, operating system, and browser. So this is also nowadays, since we have a lot of devices, manufacturer OS, so this has become very critical. So we should always focus on the device compatibility testing also. It might happen is like some application is working on some Samsung devices, not working on Vivo or some other, or like different OS version, Windows, Mac, browser, right? So we should make sure like our application is compatible with all type of devices OS which is supported. Okay. When to start system testing. So after integration testing, we can start and it should finish before acceptance testing. Okay. So this kind of some questions they actually in ISTQB they can ask, like when we can start the system testing. So just keep in mind like after integration and before UAT. Okay. Next one is yes. So performance testing, right? So performance testing is a non-functional, software testing that actually focus on evaluating how well your application will perform when there is a user load on your system, right? So like goal of this testing to like evaluate how your app will behave when like or how your app handles the expected user load. So for example, if I build an application which should handle 10,000 concurrent user, so the performance of my app is uh, uh, like consistent. Okay, it should not decrease the performance. Okay, and So there are different type of performance testing: load testing, straight, scalability, spike, endurance. Okay. So like in a stress, we try to identify the breaking point, you know, by actually increasing the load beyond the normal, capacity it should handle. Scalability means we determine how well our software can scale when we are increasing the load. Okay. In a spike, we actually see what is our system behavior when there is a sudden to extreme increase in the user load. Okay. In endurance, like we check or evaluate stability and performance over an extended period of time, like 6 months, 1 year, how our application is performing. So these are like some of the performance testing actually uh, like scenarios that can actually we should perform on our application. Okay, so any question on this testing types? Are we good? Okay, so we'll move to the next topic, static testing. So from this topic, uh, I mean, there will be always 2, 3 questions in ISTQB. So, so anyone, have you heard about static testing and dynamic testing? Anyone? Have you heard about static testing?
Yes, status testing is testing where we are testing without executing the code or it.
Yes. So, like in practical, have you done static testing? Anyone in your project? No, right? So, I mean, you know, static testing is like in a very short, like uh, you know what, like you know, when we in our STLC, maybe I can go to the STLC, and here, if you see, where it is, sorry, you can see like there are different phases, right? Requirement phase, design phase, build and development, and testing phase, right? Where do you think we can start the static testing? In which phase? So here you can see like this is our testing phase. First, static testing we can start even from the requirement phase because we don't need a code, right? As you mentioned, for software to test. So we can start, evaluating the requirement design document, right? And we can start finding the design gaps, or like there are multiple things that you can start finding. Okay, there is a gap in the requirement. There's something missing. This flow doesn't make sense. I think we have missed out some important aspect, right? So static testing is basically is a ad hoc review, checklist based review, formal review, informal review, inspection. A lot of things we can do. Okay. So in our test strategy, or like whatever test plan you are preparing, we should always try to actually include something for the static testing. Okay. So when development is happening, there is no code available for you to actually start the testing. You can actually start with the static testing and you can start raising those defects. We can call it as a static defect, something like that. I think in our Jira it is not there. but we can have another defect type as a static defect. So for static testing, as we know, like no code execution is needed. So it is performed without running the software code. Okay. So static testing is performed without running the software code. It focuses on analyzing the software structure, logic, documentation to find errors. So you go through the structure, whatever logic they have, and the documentation, and we try to find out the issues. And why this is very important? Anyone? So this is very important to find the defect at the early stage. Okay. If you are able to find the defect before the software development starts, actually you are saving, or like you are helping to reduce the cost, effort required to fix them later, right? Our software is developed after that. If we are finding like there is a problem in the requirement, there is a problem in the structure, logic, documentation, then again they have to go back, they have to change the requirement, and then development will start again. So this is very, very important. And I think, I mean, top tech companies, so they have like implemented this, and their focus is actually really very hard on the static testing. So they want to actually find out the defects at the early stage, even without running the software code. Okay. This actually involves like documentation and documentation is like very important aspect. So basically in this, we ensure like software logic and requirements are correctly captured. Okay. Now we'll talk about what are the static testing techniques. Okay. So what we can do. So first thing is like, you know, we can, I mean, have some walkthrough session, a casual review process where, I mean, we can ask a BA to actually provide a walkthrough. And on that, like we can provide the feedback, suggestion, we can clarify if we have any doubt. So I'm talking about the realistic scenarios that we can actually do in our current project, right? So we can very well ask for a walkthrough, and then based on that, we can capture the feedback, suggestion, or any clarifications. Second thing is like we can do some inspections. Okay. We can prepare some checklist documentation based on that we can do. And also like there are some tools also available, static code analysis tools that also we can use to actually find out. Okay. Any question on this? Shall we move? I think all this thing we have already covered. Okay, so just to summarize what we have covered today, so we have covered test labels, test type, and static testing. Okay, I think in this PPT, we have to now switch to the other PPT. I will share this link. Okay. So we have just seen benefit of static testing. Okay, all these things we have seen it. Okay. Okay. Next one is like uh, sorry. So review planning for the static testing. Okay, so we can define, we can eliminate, identify, select, define, and checking. Okay, so this is the steps we can actually follow, but like this is a definition one, but we can like as agreed with our like product team, we can have it like one phase as a testing for the as a static testing. Okay, now I will move to next topic. Yes. So far, like we covered the fundamental software testing life cycle and static testing, right? So any questions on this topic before we move to the test technique? So this is the topic where I think 8 questions out of 40 questions will be asked. So this is very important. So before we move, any questions so far?
One question about
Yes, please.
statistics. Yeah, so what is the best time we can say that when we perform static testing in real time?
Uh, so for example, let's say your sprint has started today.
Mhm.
Okay.
Yeah.
So all tickets will be in to do.
Mhm.
Now you and developer will actually pick those user stories for doing the coding, right? In between, you might have 1 or 2 days, okay, or three
Mhm.
days, or maybe a week also. So in that period of time, what you can do, you can perform the static testing and also you can write the test cases. Okay. So let's say on the very first day when tickets are like finalized for a sprint and sprint is started, first day you can actually perform the static testing. Go through all the tickets, user story, acceptance criteria, the structure, the logic, the diagram, HLD, whatever they have, uh, some user flow, go through it and then capture that as your feedback issues, whatever you have. And if you have any issues, you can actually share it with the like your BA or product owner first. They will review it. If it is valid, they might go and update the requirement document or user story based on that. Okay, maybe they will not allow you to raise as a defect, but in some organization, even like this is one of the KPI, how many static defect testing team have raised, right? So if they are ready, you can raise a static defect, you can also raise. Yeah,
Mhm. Yes. Thank you.
yeah. Next, most important topic, I think we will extend it for 15 minutes. Uh, so we have next very important topic is test techniques. Okay, so you must have heard about black box, white box, experience based, right? So we will first start with the black box test techniques. Okay, in this PPT, so like whatever definition which is mentioned is like similar to this, it will be asked in the question. So you can after this training, okay, once the concept is clear, you just go through it, read it, and then you will actually understand. Okay, and based on this, because most of the time you will feel like all the four options are actually almost same, but it's not same. Okay, so just read it very carefully. If you go through, you will clear ISTQB 100% because we already did, I think, 13 to 14 team members. So uh, actually cleared this. Whoever has appeared, I think all of them has cleared. Okay, so let's start with the black box techniques. Okay, so basically, black box testing is software testing method where tester evaluate the functionality of application. Okay, without looking into internal codes. Okay, so we don't actually go inside what is written in the code, and then we evaluate. So if someone who doesn't have like coding or scripting knowledge, they can actually perform the black box testing. And basically in this, we verify the input and output, what input you are giving and what the output you are getting based on the software requirement. Okay, so you so you don't need to have a knowledge of internal code. Okay, this is also called a requirement based testing. Okay, so whatever like requirement we have, based on that we actually perform the testing. Next, this is just definition. In detail we will go. Okay, now white box testing. So white box testing is like a software testing method where the internal working of the applications, okay, like from coding perspective, from the interface structure of the software, source code information. So okay, code structure, logic, implementation detail. So based on that, we actually perform the white box testing. And for this, you need knowledge of internal code. It also focus on the code coverage, and sometimes we call this a detailed testing. Okay, so there are different methods that we will see in the next slide. Okay, now experience-based testing. So anyone heard about it earlier? So basically, this is like rely on the tester knowledge and his intuition. Okay, so like if you are experienced, you have more understanding of the software, your familiarity is extreme in the similar system, then basically you can use your intuition to predict the defects that might occur and how software might behave under different conditions. Okay, and like again, as the name suggests, so there won't be any formal test design. Okay, and this is mostly exploratory in nature. So you do a error guessing, exploratory checklist, right? Based testing. So that is called experience-based testing. Okay. Now, next topic is choosing the test techniques. Okay. So again, when we create the test cases, right? Based on that, I mean, we can see like what test technique is best suited, and based on that, we can actually decide the test techniques. Okay. Uh, we will actually see in detail what test techniques we have. So basically, when you are going to choose the test techniques, you have to focus on some factors. Okay. So, like, what type of component or system is this? What is the complexity? Okay. What is the regulatory standard? Risk label, risk type, what is the test objective? Okay. So, all those things will be already actually captured uh, in the like the requirement or whatever documentation you have. Okay. Then we also have to think about like what is the tester's knowledge and skill. What are the tools which are available? What is the time, budget, which type of software model they are following, whether it is agile or waterfall, expected use of uh, software. So based on that, we actually decide on the testing techniques. Okay. Now we will start with the black box. I think, and we'll try to cover one or two because these are little complex, not complex, but yeah, it's very important to understand. And you will have questions from each of these techniques. Okay. So first is equivalent equivalence partitioning. Okay. So anyone, have you used equivalent partitioning to write the test cases earlier? Anyone? No. Okay. So basically, let me give you one example. Okay. Uh, so there is a uh, field, okay, which accept the values from 1 to, let's say, 100. Okay. In this, can you just tell me when you have to validate this particular range, what value you will use to test it? You cannot use 1 to 100, right? 1, 2, 3. Anyone? Hello? Am I audible? Hello.
Yes,
Yes,
yes, you're audible.
So, for example, I'm saying in a simple word, there is one, uh, let's say, option where you have to enter the age, for example. Okay. And that particular field accept a range starting from 1 to 100. Okay. So, for testing purpose, what kind of like values you will use to test to make sure like it is working properly?
mm, more than 100 or less than 1.
Mhm.
Those are the value we can check.
Okay.
Like criteria is from 1 to 100.
Yes. And so, yeah, you are correct. So basically, equivalent partitioning, the example is like we actually have three partition. Okay. First partition, let's say invalid, valid, and invalid. Okay. So for example, if it is accepting something between 6 to 10, so I will take the first one, okay, 6, and next one, 10. then I can try with 5, 0, 11, or like some other value. So based on this, we actually write the test cases. Okay. And this technique is called equivalent partitioning. So we are already using it to write the test cases, but in definition, maybe we are not knowing. Okay. So here you can see in equivalent partitioning. So let's say the valid range is 1 to 15. Then what will be the invalid? 16 and greater than that. So if I try 16, then I'm covering the negative. Here less than 1. Okay, some negative values. So this is for equivalent partitioning. Okay, so they will ask some, they might give some diagram, and then you have to select the correct, you know, like valid test or invalid test. They might ask, like, to test the valid scenario, what should be the range? For to test the negative, what should be the range? It is clear?
Yes.
Okay. Next one, I think this is very easy, boundary value analysis. So you must have heard. So I'll just directly come here to the example. Okay. So here the value will be mentioned in numbers. Okay. So a similar way, like you can have minimum. Okay. First two like 18, 19, and then from maximum 55 to 56, then invalid. And so we are already using it. So this can be like some examples they have given, like enter age is except 18 to 56. So like this, you have to create the boundary for character also. So based on this, you write your test cases. Okay. Some question will be like this. Okay. A text field in the application accept input as the age of the user. Here is the value allowed to be accepted by field 18 to 30. Inclusive both values by applying BAB. What is the minimum number of test cases that you require? So the minimum number should be 4 test cases, right? One, I will try 18, 30, 31, 70. So like this, they will ask question. Clear? You can also have more, like you can write one more test, 18, then 19, 29, 30, but this is the minimum. If you write this 4 test cases, so your coverage is like almost complete. Okay. They might change that same diagram, but they might change the question. So here you have to like valid boundary, which one is like suitable, what value you should try to, yeah, 17, 18, 30, 31. This is a format. Okay. So I think so we have in test techniques, we have covered equivalent partitioning and boundary value analysis. Tomorrow we will start with the decision table because I think we have already, like, time is up for today. Okay, just go through it. Once you read, then you will see like, oh, it's very easy. But in the exam, if you have not seen it, if will come, then you might get confused. Okay. All right. Thank you so much. Any other question before we close today?
One question, equivalence class partitioning is only applicable for digit or it's applicable for letters also, or it's depend on acceptance description criteria.
So basically, equivalent partitioning divides data into partitions. Okay.
Mm.
So like whatever valid values are there, right? So that are like
Okay.
accepted by the software. Okay.
It.
Invalid value is something which should rejected. Okay.
Mm.
It will not accept itself. Okay. Any more questions?
Hi, Raju. I have one question.
Mhm.
Yeah, in the case of usernames, usernames or password, how is it? Is this equivalence partitioning or a boundary value
Yes.
analysis relevant, or is some other method is followed for that?
No, we can. So here, if you see, let's say in BVA, right? So in username password, it will be written except uh, some characters, right?
Yes, yes,
Or like,
yes. Or
so
it should
it
ignore
should,
some of the characters.
yes. So you can use actually both can be used. Okay. It's not like Potesk is writing. Okay.
Okay. Okay. Thank you.
Okay. Fine. All right, then we'll catch up Monday. Have a nice weekend. Bye.
Thank you.
Thank you.
Bye.
Thank
Bye.
you.
Happy weekend. Bye
Bye.
bye.
Bye.